We have already come across with the quadratic equations in which two different real roots and only one root, but it is repeated twice and no real roots at all. Repeated real root repeated twice, I mean, because every quadratic equation has at most uh, two roots. Root means it must be repeated. That's why I have told a repeated root. One root, but it is a repeated one. And also may have two different real root, and the equations do not have any real roots at all. And now we are going to formalize such situations through some quantity called b square minus 4ac, which we are going to call it as a discriminant of the quadratic equation. Based on that, we are going to decide what type of roots are there for the equation. I will start with some three examples in each case. Now we have nature of roots. Consider three equations. Quadratic equation 2x square minus 4x plus 3 is equal to 0. 3x square minus 7x minus 6 equal to 0, and 16x square plus 8x plus 1 equal to 0. We have what is that? Is solving these equations by using a quadratic formula. X is equal to minus b plus or minus square root of b square minus 4ac divided by 2a for the equation ax square plus bx plus c is equal to 0. We have in one, what is that? In one, x is equal to minus of minus 4 plus or minus, I am taking the value a, b, c here. B square means minus 4 whole square minus 4 into 2 into 3 by 2 into 2, that is 4 plus or minus square root of 16 minus 24 by 4, that is 4 plus or minus square root of minus 8 divided by 4. Now here, which is impossible one? Which is impossible one? Since square root of minus 8 is not a real number, not a real number. Therefore, the equation 1 has no real roots. Now, in 2, x is equal to minus of minus 7 plus or minus square root of minus 7 whole square minus 4 into 3 into minus 6 divided by, what is that? 2 into 3. That is what we are going to get, 7 plus or minus square root of 49 plus 72 by 6, that is going to be 7 plus or minus square root of 121 by 6, that is 7 plus or minus 11 by 6 that is x is equal to 7 plus 11 by 6. 7 plus 11, 18. 7 plus 11 by 6 is equal to 18 by 6 is equal to 3, or x is equal to 7 minus 11 by 6. That is going to be minus 11 plus 7 is going to be minus 4 by 6, and that is minus 2 by 3. Therefore, the equation 2 has two distinct real roots. As in 3, we can see here x is equal to minus 8 plus or minus square root of 8 square minus 4 into 16 into 1 divided by 2 into 16, that is a minus 8 plus or minus square root of 64. 8 square means 64. 4 into 64, 16, again 64 by 32. That is minus 8 plus or minus root of 0 by 32. That is a minus 8 by 32 is equal to minus 1 by 8 4 ja, that is a 4, and only one root, but it is a repeated root. Now we can see in all these three examples, we have decided on the basis of b square minus 4ac, whether it is greater than 0 or b square minus 4ac is less than 0, or b square minus 4ac equal to 0. Thus, in example 1, the quadratic equation 2x square minus 4x plus 3 is equal to 0 has no real root. And in example 2, the quadratic equation 3x square minus 7x minus 6 is equal to 0 has two distinct roots. And in example 3, the equation 16x square plus 8x plus 1 has a repeated root. And why this is so? Why it happens like this? The answer which we are going to present here, because the equation 2x square minus 4x plus 3 is equal to 0, in which b square minus 4ac is equal to minus 8, which you have seen already now, minus 8, which is less than 0, and the equation 3x square minus 7x minus 6 equal to 0, in which b square minus 4ac is equal to 11, and that is greater than 0. And the equation 16x square plus 8x plus 1 is equal to 0, in which a repeated root occurs. And thus in all these cases, it is depending on the quantity b square minus 4ac, and that is the quantity b square minus 4ac in the solution x is equal to minus b plus or minus square root of b square minus 4ac by 2a of the equation ax square plus bx plus c is equal to 0. And thus we formulate the conditions on b square minus 4ac, wherein the nature of roots of the equation. Thus, 1. If b square minus 4ac is greater than 0, the equation ax square plus bx plus c has two distinct roots, namely minus b plus root of b square minus 4ac by 2a, and x is equal to minus b minus root of b square minus 4ac divided by 2a. Now, which you have seen in the equation 2, where b square minus 4ac is equal to 11, which is greater than 0, has a two distinct real root, which you have seen already. In case 2, if b square minus 4ac equal to 0, then the equation ax square plus bx plus c equal to 0 has a repeated root, namely x is equal to minus b by 2a, which repeats twice. In case 3, if b square minus 4ac is less than 0, then the equation ax square plus bx plus c is equal to 0 has no real roots, because square root of minus quantity never be a real number. And thus here the quantity b square minus 4ac is called discriminant of the equation ax square plus bx plus c is equal to 0. And therefore, the nature of roots depends on the discriminant of the quadratic equation, that is b square minus 4ac, whether it is a greater than 0 or less than 0 or equal to 0, on which the nature of roots can be decided. In summary, the quadratic equation ax square plus bx plus c is equal to 0 has two distinct real roots. If b square minus 4ac is greater than 0, the roots are equal if b square minus 4ac is equal to 0, and no real roots if b square minus 4ac is less than 0.